All right, here is the video guide for lesson 3.2.6, the last lesson actually here in chapter 3. And what we're going to be doing is applying our ideas of similarity to solve application problems. Okay, so there's actually only 2 application problems on here. They're a little more difficult. And so I'm going to give you some hints on how to set it up and kind of begin solving it. If you get stuck, please reach out because I love these kind of problems. They make good challenge problems on an assessment. Okay, and so we're going to take a look at the first one. All right, and so the first one is going to play into the second one. And so it says, if Mr. Lukey is 5 foot 9 inches tall, how tall is he in centimeters? And so we just have to convert 5 feet 9 inches into centimeters. And then you're also going to need to know your height. And so if you don't, you have to find some kind of tape measure to get your height, or just, last time you had your height taken, go with that, and convert your height into centimeters as well. Okay, this all makes sense when you get to the next slide, which is going to be the actual problem. So it says, this magical genie has come to CHS and has laid out a simple task. If you look into a mirror on the floor and you can see Mr. Lukey's eyes, this genie is going to grant you 3 wishes. Okay, the only condition is you have to do it on the first try, which means you have to stand in the right spot on the first time so that you can see my eyes. If you stand too close, you're not going to see it. If you stand too far away, you're not going to see it. And so you have to stand at the right distance. And so we're going to use this diagram on the left to figure out, okay, what is that centimeters I have to stand away, that X centimeters I need to stand away in order to see Mr. Lukey's eyes in this mirror on the ground. Okay, generally this is something we could do in class, but because half of us are virtual and half of us are in person, I've just created the model. Okay, so you can see here is you will have my height in centimeters from the last problem, from the slide before. You'll have your height in centimeters to put in this box from the problem before. Then all you have as a piece of missing information is your X centimeters. And so you can set up similar triangles here. If you can maybe see it in the diagram already, you can set up similar triangles here and solve for that X centimeters. Okay? And if you need a little more of a visual, you can always see here that, well, that's my body there. This is my line of sight. And this is my distance away. And then you have your line of sight, your body, and your distance away. Well, we can probably conclude that these triangles are similar. I won't really say much more than that. So if we know they're similar, then we can set up some kind of ratio, equivalent ratio, and solve for X. All right, that's all I'll say there. Again, if you have a question on any more information to set this up or why they're similar or how to solve it, just let me know and I can give you a couple more hints through a video. Then we get into the next one. All right, and this first slide is just going to lay out the problem. And so it's saying that they Latoya went to London and wanted to take a picture of her dad in front of the Big Ben clock tower, but then realized that the way she had her camera pointed, that the father's head was blocking pretty much the whole tower. Okay, but the important piece of information here that's going to play into the next one is she took the picture while kneeling, so the camera was 2 feet off the ground. The camera was also 12 feet from her 6 foot tall father, so we have 12 feet between the camera and her dad. And then her dad was 930 feet away from the tower. Okay, so now we're going to go to the next one, and we're going to have to sketch this situation into similar triangles and try to evaluate how we could tell that the triangles must be similar. Okay, so the first thing I like to see is, okay, the camera, we can say the camera was like right here, and if I can draw a decent dot there. The camera was right there, and that was 2 feet off the ground. Okay, we know that then we had 12 feet, I believe, between the camera and her father. So 12 feet between her and the father. And then the dad is right here. Oops, I want to get rid of that line. It's not very good. It's an actual line. Okay, and her dad is 6 feet tall, so that means above this, we could break his height into, well, there's 2 feet down here still. And then that means above that is 4 because he has a total of 6 feet in height. And then we know that he is 930 away from the clock tower, which is somewhere over here. And so then this is 930 is a distance away. The other distance over here was 12. And you can kind of see the line of sight of the camera here. Okay, and so you have triangles here. It's just about evaluating how do I know they're similar. Okay, how do I know that they're similar? And then the big question that goes with it is then, after sketching it and using your sketch, how can you determine the height of the clock tower? How can you determine the height of the clock tower way over here? Because you'll know the triangles are similar, which means the sides are proportional. How can you determine the height? Again, if you have questions on this one, just let me know, and I will be happy to help you out, give you a couple more hints in your problem to solve it, your solution. Okay, then the last problem here, so it's only 7 questions, 7 slides, is just about how did you feel? Did this lesson make sense? Can I feel like I can apply these similar triangles to other problems? All right, if you're stuck on this one, this was a good one to reach out on, but also remember you can join synchronous sessions during our class time. So today, what day is it today? It's Tuesday after that weird break, and so we actually have 135 today. So if you're hour 3, you could join at 10. If you're hour 5, you could join at 1, and the same thing goes for hours 4 and 6 tomorrow. You can join at your class time, and we can, answer questions. I'm happy to answer questions in there. But again, if you don't want to do that, it's my expectation that you do, but you could also email me questions as well.